Alright, this is Thursday, lesson 6-2. On page 301 is where the lesson will start. I'll probably work all the problems out of the homework section and then assign your homework, but primarily the lesson is going to be about finding inverses of functions. And so there's some important stuff right here. Basically, to find the inverse of a function, like if you're looking at ordered pair AB, the inverse is going to be the ordered pair BA. So essentially, to find inverses, you can swap their domain and range. So the domain and range will swap. If we have f and we find the inverse of f, we're going to call that f to the power of -1. That's how we indicate inverses. Let me see if there's anything else on this page, and we'll jump straight to the homework. Alright, if we just jump right to it, on page 305, your homework section, the first couple problems are just super simple. How do you find the inverse of -8,6? That's going to be 6, -8. And like I said, you should just get this one. This will be -2,6. Like I said, it's kind of stupid easy. All you have to do is swap the domain and range, and you have found the inverse. So 1 through 4 should be super simple. When we move down to the next section, it's not quite as easy. When we're looking at an equation, we are going to do the same thing. And by the way, f of x is just y, and so we will do the same thing here. Let me put my work somewhere. We will swap x and y, so we're going to do the same thing. So this will be x equals, I'm going to put my work over here. So if I have y equals x plus 2, the inverse is going to be x equals y plus 2. Now, the only problem with this, or not a problem, the work that you actually have to do to get the answer is all of these answers are going to be solved for y. So if you're a good equation solver, you're good to go here. This will be easy. We just have to solve this thing back for y, and you're done. So this is how you start it, okay? Swap x, y, and then the answer will be solved back for y. So I'm going to -2, -2, and my equation solved for y is x minus 2 equals y. So the inverse of y equals x plus 2 is y equals x minus 2. Let's do a couple more. Number 6. Same thing, that's your y. So first step, and people usually have the hardest trouble with the first step. How do I get started? Well, to start finding inverses, you swap x, y. So, and then this equation has to be solved back for y. And again, since 6th grade, you've kind of been doing this. So this equation solved for y, I'm going to divide by 5, is y equals x divided by 5. Let me look at a couple more. We'll go to the next page, see what you can do with some of this stuff. Number 8, we're going to start with y equals x minus 4 divided by 3. So to start finding the inverses, we'll say x equals y minus 4 divided by 3. And then again, it's just equation solving. So we're going to solve this thing back for y. So we will times 3 to both sides. I'll have 3x equals y minus 4. And I'll finish this thing up by adding 4. Like I said, you've done this in 6th grade, 7th grade, 8th grade, freshman year. We spent some time in chapters 1 and 2 solving equations. Anyway, the inverse of x minus 4 divided by 3 is 3x, or y equals 3x plus 4. And again, if you're looking at this, all this should have opposite operations in it. We have a divide 3, so we have a times 3. We have a minus 4, we have a plus 4. You can't just swap them. You do have to solve it, because orders of operations can make them look a little bit different. I don't think anything else is too bad there. So let's go to the next page. Alright, so the last little section that you're going to do is 17 through 22, or some of those problems. And basically, they want us to determine if these equations are inverses. You can use a little bit of common sense, because we've got a yes or no answer, but we're going to have to prove it mathematically. There's 2 ways to do it. And again, we can use some common sense. Like What are inverse operations? Well, if I'm looking at a times 2, I better be looking at a divide 2 in the answer. And of course, I know that's times 1/2, but that's the same thing as divide 2. If I'm looking at a plus 3 in the problem, I should be looking at a minus 3 in the answer. So if I was going to guess, I would guess that these are inverses. Now, there are 2 different ways to verify it. The book teaches it a little bit different than I think. Essentially, to determine if f and g are inverses, I would simply just find the inverse of f. So I'm going to say x equals 2y plus 3. And if I get g as an answer, or something equivalent to g, it's going to be hard for some of you, then they are inverses. So I get x minus 3 equals 2y, and I will finish this off by dividing by 2. And I don't really like to simplify mine, so I get y equals x minus 3 divided by 2. Now, is that the same thing as g? So that's going to be the hardest thing for you, depending on how you simplify this. And the answer actually is yes. If you think about this, in g we would distribute, that would be 1/2 x times 1/2 times negative 3. And I already told you timesing by 1/2 is the same thing as dividing by 2. So what do I have here? I have x divided by 2, and I have negative 3 divided by 2. So the answer here is yes. And I think the easiest way to do it is just find the inverse of f, and if you get something equal to g, then they are inverses. Now the book does it a little bit different, and it does it using composition of functions, and I think it's important for you at least to see, maybe try. The explanation of how the book wants you to do it is right here. And basically they want you to do it using composition of functions. If you do f composed with g and get x, and also do g composed of f and get x, then that verifies that they are inverses. So you do have to do f composed with g and g composed with f. Sounds difficult. It's not that big of a deal. Excuse me. Let me look at one. We already know 18 is a yes, so let me show it to you. If I do f composed with g, what does that look like? Well, I'm going to put g inside of f. So 2 parentheses x plus 3. And then inside of that is going to be 1/2 x minus 3. And that might be too much for some of you. But I can simplify this in just a second. Now, if I simplify this, and there's several ways, we could distribute the 1/2 and then distribute the 2, but also you're basically distributing a 1/2 and a 2, and those will go away, and that will leave you with x minus 3 plus 3. And what is x minus 3 plus 3 but x? So when I do f composed with g, I do get x. If I go the other way, so g composed with f, I'm going to say 1/2 parentheses, and then I need to make another parentheses for that x, because what am I going to put inside of it? 2x plus 3. And then I have a minus 3 right here. So if I'm looking at this and simplifying it using the order of operations, I do have a parentheses 2x plus 3, but nothing to distribute, or I can distribute this 1/2, but I would like to do it this way. Essentially, I'm going to have 1/2 parentheses just 2x plus 3 minus 3. Right? These parentheses right here in light pink, there's nothing to distribute, they're not really needed. What happens when I have a plus 3 and minus 3? It goes away. And so when I distribute this, I'm really just doing 1/2 times 2, and 1/2 times 2, x is just x, so I get the identity. Anyway, that's your lesson. The way I did it the first time is a whole lot easier, I think. Just find the inverse of f, and if you get something equivalent to g, then the answer is yes. You should get this done in class, because I don't think this is a very long video. And we'll go from there.